What is up everyone, Nick here, and in today's video we're going to be covering how I built not one but two different 3D printed helmets from the TRON universe. My Rinzler helmet from TRON Legacy and my Ares helmet from TRON Ares. Now originally this video was just going to cover my Rinzler helmet, but I ended up getting sick and I didn't get the edit done in time. And on top of that, both of these helmets are very similar, so I figured we'd just cover both helmets in one video. Both of these helmets were made using 3D files by Do 3D, which are currently being updated right now to improve the visors based on feedback I gave them, but more on that later in the video. If you've been with the channel for long enough, you might remember that we've already built a Rinzler helmet, but if you haven't seen that video already, I'll link it up above for you to go check out. This older version of the helmet was actually fully 3D printed out of resin by this channel sponsor, PCBWay. Now PCBWay, if you don't know it already, is this channel sponsor, and they are the industry leader when it comes to PCB manufacturing and 3D printing solutions. From custom circuit boards to innovative 3D printed prototypes, PCBWay offers unparalleled quality, fast turnaround times, and competitive pricing. And currently they're celebrating their 11th anniversary, so if you want some exclusive coupons for some purchases, go check out the links in the description. Now, as good as this helmet was for the little amount of work I had to put into it, essentially all I had to do was to tint the inside of the helmet and then clear coat it and then install the electronics. Since it was fully 3D printed out of resin, it's not only extremely heavy, but it's also extremely fragile. I actually broke the back panel into like 5 different pieces the day before I left for a con and accidentally dropped it. So it's not exactly the best for cosplay, but it gets the job done and it looks really good while doing it. Also, visibility was a huge issue. Since it was 3D printed out of resin and it was very clear, it wasn't quite optically clear, meaning it was a little bit blurry when looking through the resin, and on top of adding the black spray paint tint onto the inside of the helmet, it just really messed with my ability to see. Plus, this was the first time I made a helmet that I would wear for long periods of time. Usually when I'm wearing an Iron Man suit, I can just open the faceplate and have fresh air, but I can't really do that with the Rinzler helmet, so it got really foggy really quickly. So with the new Rinzler helmet, and especially with the Ares helmet, I wanted to find solutions to all these problems and refine the process a bit. So let's talk about how I 3D printed these. Both helmets were printed using Polymaker Polylite ABS, and everything was done on the Creality K2 Plus, which honestly handled this build like a champ. It has a 350mm cube build volume, which is massive for cosplay pieces and easily fit every single part I needed. Even the larger armor components I've been working on for my Ares cosplay. More on that in another video. But what really impressed me about the K2 Plus is its reliability with high temp filaments. I've used a ton of enclosed printers in the past, and the one thing most of them struggle with is laying down a clean first layer when the enclosure heats up. The K2 Plus, not a single print failure, not one. Well, except for the time I used an apostrophe in the file name, which messed with the printer's ability to read G-code. Totally my fault. I did run into a really weird banding issue with some of my early prints, and at first I thought it was some sort of Z banding. But the reason I was getting those print artifacts in the first place was because the K2 Plus comes equipped with an internal temperature regulation system. That means that if the internal temperature of the enclosure gets too warm and passes a certain threshold, it'll start to suck out the hot air from the enclosure to keep the temperature down. But the issue is when you're 3D printing high temp filaments that require a heated enclosure, it keeps setting off the temperature regulation system and it keeps screwing with the filament. So as the 3D printer is, 3D printing, it will 3D print a bunch of layers at a high temperature, and then suddenly all the hot air in the build volume gets sucked out, and now the plastic is cooling down really quickly for the next few layers. So rinse and repeat, and you get this weird banding artifact. But once I figured out what the issue was, all I had to do was disable it in the slicer and the problem just went away. So to wrap up my thoughts about the K2 Plus, it's a fantastic machine. It's just that there's a lot of weird kinks when it comes to the slicing software and some of the features in the printer. And on top of that, most of the filament presets need some adjustment because they're just way too fast and it really causes some issues with the print quality. But once you have your slicing presets fine-tuned, it works really well. So I've been talking a lot about high temp filaments, and that's because I actually 3D printed these two helmets out of ABS. ABS has become my go-to filament when it comes to projects because it sands really easily. So it really cuts down the amount of work and the amount of time I spend on projects, which means I'm able to do way more in way less time. The only downside is there is a big learning curve to learning how to 3D print with ABS, but once you have that experience, it's actually quite easy. So while the helmets were 3D printed out of ABS, the visor bucks for vacuum forming were actually 3D printed out of carbon fiber ASA. Now, if you've seen my earlier videos, like my short form content covering the Rinzler helmet and the Ares helmet, You already know that one of the big upgrades with these two helmets has been the vacuum formed visors I've made for both of them. For Rinzler, I vacuum formed the entire front visor out of a thick sheet of polycarbonate, and for Aries, I used PETG. But both visors were formed using the same machine, the Formart 2 by Maillard. The Formart 2 by Maillard is hands down one of the most advanced desktop vacuum forming machines on the market. And honestly, it's a game changer for makers like me. This all-in-one unit features a massive 47 by 27 centimeter work area, making it the largest desktop vacuum former out there, which is perfect for projects like these full face visors. What makes it stand out is how complete the setup is. There's a built-in vacuum pump, so you don't need to hook up a shop vac or do any janky hacks to get a clean form. It also has automatic material detection, which scans a QR code on Maillard's plastic sheets and loads the ideal settings instantly. Plus, it's packed with smart features like automatic mold release, a vacuum sensor for better material control, and rapid cooling fans to speed up production. It also heats up 3 times faster than typical setups, has a preheat mode to improve results, and supports a wide range of materials, even third-party sheets. And if you're like me and care about precision and repeatability, the Formart 2 delivers incredibly clean, professional quality forms every time. So yeah, the machine did a lot of heavy lifting when it came to making these visors, and it honestly opened up a whole new workflow for my prop builds. The drying feature was especially handy when working with the polycarbonate sheet for the Rinzler helmet because polycarbonate is hygroscopic, meaning it takes in moisture. So when you vacuum form it and you heat it up really quickly, it forms bubbles in the plastic. So before I did my vacuum form, all I had to do was dry off the sheet in the rack, and once I was ready to vacuum form my visor, it was completely effortless and left no bubbles in the visor. Now that's not to say that the process of vacuum forming the visors was perfect. I actually had quite a few issues, but they were literally all my fault. For example, when I 3D printed the very first prototype buck for the Rinzler helmet, I 3D printed it vertically out of ABS. And that was because I was 3D printing it on the S1 Pro, and I was having a really hard time with bed adhesion, so I didn't want to print it flat, but the buck still ended up being slightly warped when I 3D printed it. So when I went to go use the vacuum former for the very first time, I was unable to get good pulls because the vacuum just wouldn't set in all the way. So I started changing a bunch of settings on the Formart 2 to fix this, but that only made things worse because it turns out it wasn't an issue with the settings, but rather the buck. So once I fixed the issue I had with the buck, I was able to get a really good vacuum pull for the Rinzler helmet, but it also crushed my buck because it was hollow. But I was still able to get a really good polycarbonate vacuum pull out of it, so I still used it. But on my future attempts, I did end up reprinting the buck with some bracers inside and 3D printing it out of carbon fiber ASA. Now, like I said, the Rinzler helmet has a vacuum formed polycarbonate visor, which is around 1.5 millimeters thick. It's quite thick. So between the plastic being way too thick for what the helmet was initially designed for, and on top of the buck being curved, I had a really hard time installing the visor in the helmet. So I got quite a bit of glue on the outside of the helmet, and on top of that, it doesn't quite align with the seams, so there's like big seams all around the edges of the visor. Now, this isn't really an issue with the Aries helmet, which I use just standard 0.8 millimeter PETG for. What is an issue is just the size of the visor and how much the plastic actually stretches. So with the Rinzler helmet, for example, it's actually quite thick because it didn't really need to stretch over a big object. So as you can see, this is the visor itself. All of this extra stuff here on the sides gets cut off before the installation. Meanwhile, with the Aries buck, you not only have this front half right here, but you also have these sides which are part of the visor. So beyond this edge right here, the plastic has to stretch to make it all the way down the buck. And as a result, it becomes way thinner. And if we take a look at the helmet itself, we can see that the front of the visor doesn't really push in all that much when you press on it. But if you push on the sides, it's very, very thin. And while I was putting the finishing touches on the helmet, I actually ended up breaking the visor slightly on this side. The corner of the visor hit something and it broke. So I'm going to be making a brand new Aries helmet really soon, and the visor is only going to be this front half, while these side panels here will be part of the 3D printed helmet. So here's hoping that will make it a lot less prone to breaking. And when it came to tinting the visors black, I just followed the tutorial by Punish Props on tinting visors. All it is really is getting water up to a certain temperature, like 140 Fahrenheit, and then mixing in a packet of fabric dye. And once that's all nicely mixed in, you can just dunk in your visor for 5 minutes at a time, take it out, quench it in cold water, and then rinse and repeat until your visor is correctly tinted to your taste. So far I've talked about 3D printing the helmets, making the visors. Now we get to actually talk about the finishing touches I made on the helmets, like paint and the electronics. So when it came to post-processing the helmets, I kind of just did the same steps that I always do, which is to say I used an electric electric sander with 120 grit sandpaper to remove the vast majority of the layer lines on my 3D prints before I did anything else. And when it came to the Rinzler helmet, it was quite easy because it's all flat surfaces. So I did 100% of the sanding just with an electric sander. But when it came to the Ares helmet, there's a lot more intricate details, which means I couldn't get a lot of it with my electric sander. So I had to do quite a bit of sanding by hand with regular 120 grit sandpaper. But once that step was done, I coated it in a nice thick coat of filler primer. And once the filler primer was dry, I looked for any imperfections, any layer lines I missed, and I applied Spot Buddy. And if there were any deep imperfections that needed to be filled properly, I used regular Bondo. And once all of that hardened, I sanded my 3D prints with 220 grit sandpaper on my electric sander, and again with regular sandpaper whenever there were any nooks and crannies I couldn't reach. And once more, I applied a huge layer of filler primer and inspected it for any imperfections. Now, usually when you do the first two steps right, there aren't a lot of imperfections to fix, but if there was anything I missed, I would just rinse and repeat that step until all the imperfections were gone. And once all my 3D prints are primed and there's nothing left, I wet sand all my 3D prints down with 400 grit or 800 grit. And by this point, everything is ready for paint. Now, when it came to actually painting the helmets, I went with two separate approaches. With the Rinzler helmet, I decided to go with a flat black acrylic spray paint and then clear coat it with Duplicolor's 1K gloss clear coat. Now, this worked really well. The only issue is the 1K clear coat takes a long time to fully harden, which means I waited at least a week and a half tops to make sure it was fully hardened before I actually started doing any of the installation of the electronics. That way I wouldn't be smudging the clear coat with thumbprints and whatnot. Now, with the Ares helmet, I decided to go with a little bit more of a creative approach. Since we don't have a lot of reference material when it comes to the actual helmet, it's hard to gauge what the colors actually are. So for the helmet itself, I decided to use Duplicolor's Perfect Match system. So I painted the helmet with a base coat of black mica spray paint. Now, this spray paint is very close to gunmetal because it has like a metallic flake in it, but once you add the 2K clear coat on top, it actually darkens quite a bit. And for the silver accents, I just used a random silver I found on the shelf that was also Duplicolor Perfect Match. And then I sealed the entirety of the helmet in a Spray Max 2K clear coat. Now, one of the reasons I love working with Perfect Match spray paints when it comes to one-off projects like this is because number one, they dry extremely fast, and number two, they're very easy to handle. For example, masking off the silver accents is a breeze because there's no tape residue after you remove the tape. And this was within like a half hour of actually painting the helmet in that black mica. And the Spray Max 2K is really good too because it's a 2K clear coat, meaning it's two parts. So the clear coat for the helmet was fully hardened within a day. Now, the only downside is it's actually quite expensive for a rattle can. And on top of that, it's only good for about 48 hours once you've actually activated both halves of the 2K, because eventually it's gonna harden in the can. So once I gave both the helmets enough time to fully cure with their paints, I started working on the electronics. Now, when it came to actually making the electronics for the Rinzler helmet, I followed a lot of the same steps as my jacket tutorial, meaning I used the exact same RGB strips and the exact same SP611E controller. Now, the 611E is really useful because it runs on 5-volt power, and on top of that, you can actually just control it via a Bluetooth app. And if that weren't enough, you can actually sync up multiple of these together, which means I can control both the helmet and the jacket simultaneously. And on top of that, I added 2 cooling fans inside the helmet to keep the visor from fogging up. Meanwhile, with the Ares helmet, I decided to do something a little bit more custom. I designed my very own circuit board. It has multiple connectors on it for all the RGB lights, and it also has 2 connectors for the cooling fans, which all link up to a kill switch. That way I can turn on and off the fans. And on top of that, it has a USB-C port. That way I can just plug in a USB-C connector to power the whole thing. And it's all being controlled by a ESP32 S3 Mini. Now, the reason why I went with the ESP board to control all the lights is because in my Ares costume that I'm going to be showing off really soon, I'm going to have ESP32s across the entire suit to control multiple sets of RGB lights. And since I'm going to be in full cosplay, I don't really have access to my phone to change the color of the lights. So in my disc, I'm going to have an ESP32 that is going to control all the lights in the suit, including the helmet, wirelessly. That way, with just a click of a button, I can switch all the lights from red to white. But since I only have the helmet right now, I needed a way to be able to toggle the lights. So I went ahead and installed a magnetic reed switch in one of the ears. That way I can just use a magnet and change the colors of the lights. And on top of that, since I'm using my very own board with code I wrote to actually control the lights, that means I have full control of the animation cycles. So instead of just having a smooth transition to change the color of the lights, I decided to replicate something that I saw in Tron Legacy. So when Rinzler goes into the sea of simulation and effectively dies, his lights change from orange to white, but when they do, they flicker, turn off, and then switch to the different color, which is exactly what I replicated here with this helmet. So you can see as it changes, it flickers, turns off, and then changes color. And on top of that, I used a magnetic pogo connector for the backplate. That way I can just disconnect the backplate with the RGB lights super easily when taking off and putting on the helmet. So that completely eliminates the need to connect and disconnect wires when putting on and taking off the helmet. Now the files are still a work in progress. I'm still improving them with Do 3D to make them even easier to build. And when it comes to the PCB in the Ares helmet, I will be showing that off in a future video, along with alternate versions I designed for the Ares suit. So make sure that you are subscribed and you hit that notification bell. That way you're alerted as soon as that video comes out. If you have any questions about this build or you want to give me suggestions for future builds, please let me know in the comments down below. And a huge thank you again to PCBWay for sponsoring this video and for sponsoring the channel. And another huge thank you goes out to MyYard for sending me the Formart 2 for this project, and to Creality for sending me the K2 Plus to test out. And I will see you all in the next one.